Howdy Rock Buds, it's Rock Papa. Hope you guys are doing well wherever you are in the world. Today we're going to talk about a very interesting topic and one shrouded in a lot of controversy, and that is the Carolina Bays. We're going to find out what a Carolina Bay is. We're going to find out where the Carolina Bays are located, and we're going to look at some of the features, geologic and morphological features of the Carolina Bays, and we're going to look into some of the theories as to what formed these Carolina Bays. Hey Rock Buds, I got interested in these Carolina Bays through a conversation with a colleague of mine and a family member by the name of Cottrell. Chris is an educator in the field of geology, and he has spent many hours researching these Carolina Bays. So I will put a link in the description below to his YouTube channel that I find very interesting. And as usual, I hope you find this video useful and interesting. If so, please subscribe. And thank you so much to all my wonderful subscribers. I appreciate you so much. So here we go. Carolina Bays. Carolina Bays are elliptical depressions in coastal plain sand. They are up to 10 feet deep and range in size from 1 acre up to 1,000 acres. There are about 500,000 Carolina Bays, and they are located all up and down the eastern United States in the coastal plain physiographic province, and interestingly enough, also in the sandy areas of Nebraska. In Alabama, Georgia, North and South Carolina, they are called Carolina Bays. Up in Maryland, they're called Maryland Basins and Delmarva Bays on the Delmarva Peninsula. And in Nebraska, they're called Nebraska Rainwater Basins. And Native Americans called them moccasins, which means a swamp or pond on a hill. Here's a LiDAR map of Carolina Bays that just shows you the nice elliptical shape of them and the different sizes. And you'll also notice that they are oriented in the same direction. A lot more about this later. And here's another LiDAR image that just shows you the sheer number of these Carolina Bays located in the coastal plain province. In this picture, every dot shows the location of a Carolina Bay. And by the way, Rock Buds, LiDAR is just a mapping system that's able to remove all the vegetation from the land and show the topography, the ups and downs, in great detail. So let's just have a look at some of these Carolina Bays. Some take the shape of lakes, and they provide a lot of good wildlife habitat and fishing opportunities. Some are like swamps, like this, where you have islands of cypress trees and lots of edge for wildlife to reside in. Some are completely forested, like this one. And in the upper left hand of this image, you can see where they have drained the Carolina Bays and are using them for cropland or pasture land. Hey Rock Buds, now let's get into a little more detail on the structure and the orientation of the Carolina Bays. This map shows where the Carolina Bays are located, with the highest concentration of them in North and South Carolina, and the fewer located south and north of there. And the dotted line, which shows the greatest extent of them going inland, actually marks the fall line, which is the boundary between the Piedmont and the coastal plain. So they're all in the coastal plain physiographic province. And here's a map that just shows you what cities actually are right on the fall line, just to get you oriented. Back to this LiDAR map, it shows us that within a given area, all the Carolina Bays are lined up directionally with each other. In this case, which is the Carolinas, they're oriented northwest to southeast. Here is a map that's a kind of giveaway as to one of the theories for the origin of the Carolina Bays, but it shows you how the orientation changes with the location in the coastal plain. And it also shows the orientation of the Nebraska and Kansas rainwater basins. Do you find it rather curious that all these lines of orientation converge in Michigan? We'll talk more about this in a little bit. One of the interesting features of the Carolina Bays is that they have a raised sand rim that you can easily see in this photograph. In this picture, the rims are most pronounced on the southeastern edge of the ellipse, but they do actually kind of extend up toward the northeast side. The black arrows in this LiDAR image show that one of the interesting features of the Carolina Bays is they have this overlap thing, maybe where one bay overlaps another, or either the raised edge on the southeast side is duplicated some way. So here's just a summary of the features of these Carolina Bays. They have an elliptical shape, and in a given area they are all oriented in a similar direction. Sometimes the rims seem to be overlapping, and they do have that raised sand rim. Hey Rock Buds, now let's investigate the question, what caused the Carolina Bays to form, as well as the Nebraska and Kansas rainwater basins? There are two main theories about this. The first one, and the oldest one, is that they were caused by the action of wind and water upon the sand. And the next, more recent theory is that they were caused by a meteor impact. So we'll look at each one of these ideas in a little more detail. The oldest and perhaps the most widely accepted idea about the origin of the Carolina Bays is that during the Pleistocene or Ice Age, which lasted from about 2.5 million years ago to 11,700 years ago, strong bimodal winds were blowing, and that just means that these winds would blow strongly from what is now the northwest, and then they would shift around and blow strongly from the southwest, and this was repeated over and over, eventually imparting the oval shape, uniform orientation, and raised sand rims of the Carolina Bays that we see today. An associated study using various dating techniques found that the Carolina Bays were created before 11,700 years ago, which would be the end of the Ice Age. Another study found that the Carolina Bays that they looked at had formed in sand dunes that were dated at 23,600 years ago, which means that these bays formed after 23,600 years ago. And yet another study found that the Carolina Bays they looked at had formed above an undisturbed layer that contained Pleistocene marine shells. Hey Rock Buds, the bottom line with the wind and water theory is that these Carolina Bays formed at different times during the Pleistocene, and more specifically between 23,600 years ago and about 11,700 years ago. And now let's look at the meteor impact theory. This theory says that a meteor hit Michigan, either the lower peninsula or actually in Lake Michigan, and it hit at a very slanted or oblique angle, slamming into the huge ice sheet that existed at that time, ejecting these ice fragments that eventually fell in the eastern coastal plain as well as Nebraska and Kansas, thus creating the Carolina Bays and the Nebraska and Kansas rainwater basins. Let's look at two ideas about the timing of this meteor impact. The first idea says the meteor impact was at about 12,900 years ago, right at the end of the Pleistocene Ice Age. This impact timing idea actually claims that the meteor facilitated the extinction of the North American megafauna. We are talking about mastodons and mammoths and camels and giant ground sloths, huge Irish elks and giant bison, etc., as well as bringing to an end the Clovis culture, prehistoric hunter-gatherers in North America who made a specific kind of spear point called the Clovis point, and who hunted the megafauna and likely also contributed some to their going extinct. Hey Rock Buds, the idea associated with this 12,900 years ago meteor impact is that the effects of the meteor brought on a period of intense cold that began around 12,900 years ago and ended about 11,700 years ago. And scientists call this very cold period the Younger Dryas period, and it contributed to the extinction of the megafauna and the extinction of the Clovis culture. Hey guys, Nova did a super interesting video on the Younger Dryas meteor impact hypothesis. And I think you would find it very interesting. I'll put a link in the description below. It mentions the black mat idea and also the idea of nanodiamonds as evidence for this impact. And finally, let's look at a meteor impact theory that says that the meteor impact was actually around 780,000 years ago and caused or contributed greatly to the mid-Pleistocene transition. So what is the mid-Pleistocene transition? Well, before the transition, the glaciers would come and go on about a 40,000 year cycle. But after the mid-Pleistocene transition, the glaciers came on an average of 100,000 year cycles. Ideas associated with this theory are one, that the impact brought on the mid-Pleistocene transition. Two, that it actually caused a split between modern humans and Neanderthals, called evolutionary bottleneck. And three, that it created the massive Australasian tektite field. Tektites are beautiful multicolored hunks of glass that form when sediment material ejected from a meteor impact gets so hot that it melts to form glass. Hey Rock Buds, Chris Cottrell, who runs the DabblersDen YouTube site, is probably one of the major proponents of the mid-Pleistocene transition impact as the cause of the Carolina Bays. There's a tremendous amount of interesting information on Chris's channel, so check out the link in the description below. Okay, excellent Rock Buds, that's it for the Carolina Bays. Thank you so much for watching. I have not covered much about the pros and cons of each of these theories or hypotheses. If you're interested, there's plenty of material on YouTube University and Google University for you to dig in deeper. So once again, if you liked this video and found it interesting, please subscribe. And this is your Rock Papa saying to all my most excellent Rock Buds, happy rock hunting. Papa out.